The Milky Way began as one or several small overdensities in the mass distribution in the universe. Shortly after the Big Bang 13.61 billion years ago, some of these overdensities were the seeds of globular clusters in which the oldest remaining stars in what is now the Milky Way formed. Nearly half the matter in the Milky Way may have come from other distant galaxies. Nonetheless, these stars and clusters now comprise the stellar halo of the Milky Way. Within a few billion years of the birth of the first stars, the mass of the Milky Way was large enough so that it was spinning relatively quickly. Due to conservation of angular momentum, this led the gaseous interstellar medium to collapse from a roughly spheroidal shape to a disk. Therefore, later generations of stars formed in this spiral disk. Most younger stars, including the Sun, are observed to be in the disk. Since the first stars began to form, the Milky Way has grown through both galaxy mergers, particularly early in the Milky Way's growth, and accretion of gas directly from the galactic halo. The Milky Way is currently accreting material from several small galaxies, including two of its largest satellite galaxies, the Large and Small Magellanic Clouds. Through the Magellanic Stream, direct accretion of gas is observed in high-velocity clouds like the Smith Cloud. Cosmological simulations indicate that, 11 billion years ago, it merged with a particularly large galaxy that has been labeled the Kraken. However, properties of the Milky Way such as stellar mass, angular momentum, and metallicity in its outermost regions suggest it has undergone no mergers with large galaxies in the last 10 billion years. This lack of recent major mergers is unusual among similar spiral galaxies. Its neighbor the Andromeda Galaxy appears to have a more typical history shaped by more recent mergers with relatively large galaxies. According to recent studies, the Milky Way as well as the Andromeda Galaxy lie in what in the galaxy color magnitude diagram is known as the Green Valley, a region populated by galaxies in transition from the blue cloud galaxies actively forming new stars to the red sequence galaxies that lack star formation. Star formation activity in Green Valley galaxies is slowing as they run out of star-forming gas in the interstellar medium. In simulated galaxies with similar properties, star formation will typically have been extinguished within about 5 billion years from now, even accounting for the expected short-term increase in the rate of star formation due to the collision between both the Milky Way and the Andromeda Galaxy. In fact, measurements of other galaxies similar to the Milky Way suggest it is among the reddest and brightest spiral galaxies that are still forming new stars, and it is just slightly bluer than the bluest red sequence galaxies.